Okay, number 50 gets into our law of sines and cosines problems. So we'll review those formulas as we go through these. So on number 50, they asked me to draw a triangle. Let's draw an obtuse triangle here. And it asked me to make angle C be 102.3, and angle B is going to be 28.7, and then side B, which is going to be across from angle B, is going to be over here 27.4. So let me start by making a little chart to write all of our sides and angles in. So to solve this triangle, I need to find all of our sides and all of our angles. So 28.7 and 102.3. Okay, so on this one we have given information here on two angles and the side that's not in between them. So this is going to be an angle side, which means that I'm going to use the law of sines. And when we're working with law of sines and cosines, we need to be in degree mode because these were given to us in degrees. So check your calculator first and make sure you're in degree mode. All right, then I'm going to start by finding angle A. So I know the three angles of a triangle are going to add up to give me 180 degrees. So let's start there, and that's going to give me that A is 49 degrees. All right, so I'm going to set up my law of sines, which is A over the sine of A, and B over the sine of B, and C over the sine of C. And the only trick to this is to make sure that you only work with two of them at the time, and you want to work with two that don't have a variable. So I'm going to start by working these two together right here, and I'm going to cross multiply. So when I cross multiply, that's going to give me A times the sine of 28.7, and over here, multiply this way, gives me 27.4 times the sine of 49. So to find A, I just need to divide. Alright, so if you need to put this in a couple of different steps, you can. But if you have on your calculator alpha F1 number 1, that's really helpful too. So I'm going to put in my 27.4, and I'm going to have the sine of 49. And then on the bottom, I'm going to have the sine of 28.7. And let's round these to 3 decimal places, so that's going to give me 43.061. Okay, next I'm going to use the other two fractions together. Again, I want to use some that only have one variable, so I'm going to use these two together to help me find C. So that's going to be this one right here. And I'm going to cross multiply, so that gives me C times the sine of 28.7. And cross multiply here gives me 27.4 times the sine of 102.3. And again, divide. So that right there is what I'm going to put into my calculator. And again, I'm going to use alpha F1 number 1 when I can. So 27.4 times the sine of 102.3. And then I'm going to divide by the sine of 28.7. And that gives me that C is 55.747. And don't forget to use your hinge theorem. You can always go back and check and make sure that your biggest side was across from your biggest angle right here, and your smallest side was across from your smallest angle right there. So a good way of checking your answer. Okay, on 51, we're still working with an obtuse triangle here. Or we were not told that it was right, so we'll go ahead and assume that it's obtuse. Let's see here. I want A to be 42, and I want side A, which is going to be across from angle A, to be 22. And I want side B, which is going to be across from angle B. So let's make this one B down here and C up here. So side B is going to be 12. So I've got the two sides and the angle that's not between them. So this is going to be a side-side angle. And with a side-side angle, I need to work with triangle number 1. And triangle number 2. So this is going to be an ambiguous case question. These are the ones where we have to assume that there are two triangles, until we can prove that there are not. Alright, let's see here. Same information down here. All of our given information stays the same. It's not going to change. Okay, so let's start by using the law of sines to set this up. So I'm going to do A over the sine of A, and I'm going to do B over the sine of B. Alright, let's cross multiply. That's going to give me that. And then what I'm going to do is I'm going to divide by my 22, and I'm going to move this over with an inverse sign. Oops, I forgot to do my inverse sign. Alright, so put all of that into your calculator. Clear out what we had. So I'm going to do second sine alpha f1 number 1 to get my fraction. So 12 sine of 42, and I'm going to divide by 22. And that's going to give me B in the first triangle, so 21.406. In my next step, I want to get B in the second triangle. So I'm going to store this thing as X so that I can use it again. And to move to the second triangle, I'm going to subtract this 21.406. I'm going to put an X right there. And that gives me 158.594. So here's where we run into a problem with the second triangle, because if I go to find C, I know that the three angles of a triangle should add up to be 180 degrees. And on this one, I'm already at a negative angle right there, which we don't talk about negative angles with triangles. So I only have one triangle that exists on this one, but we do have to go ahead and check and make sure. Alright, so back up here, I'm going to take 180 and subtract my 42 and subtract my 21, which we've stored as X. So that's going to give me 116.594 degrees. And lastly, I'm going to use the law of sines to help me find C. Alright, so that's going to be, I'm going to go back and use A again. So I'm going to use A over the sine of A equals C over the sine of C. And this right here is right there in my calculator, so I'm going to use second answer to help me with that. So C sine of 42 equals 22 sine of 116. And then I'm going to divide by that sine of 42. So I'm just going to do that in my calculator. So I'm going to do alpha f1 number 1 for my fraction. And I'm going to do 22 sine. And then I'd like to use all of these decimal places. So I'm going to put in second and my negative to get that answer back in there. And then I'm going to divide that by the sine of 42. And that's going to give me 29.400. So only one triangle existed, and there's the answers to that. Okay, so we'll pick up with the next ambiguous case problems on the next video.